Graphs of polynomials. Describe the graph of the function without using a graphing utility, so that means no graphing calculator, software, or graphing app. Give the x and y intercepts, if there are any, and describe end behavior. Well, in the previous recording, I showed you how to find the x-intercepts for this exact function. So I'm just going to copy them down here because it was actually a whole recording in itself. It's a multi-step process. So the zeros that we found were -2, 1/4, and 5. Oops, that should be 1/4. And 5. And if you're not sure how to find those zeros given this function, then please watch the recording right before this one about zeros of polynomials. Now, the y-intercept is much easier because the y-intercept is the point on the graph where x is 0. So if I make this 0, and I make this 0, and I make this 0, that means each of these terms is going to be equal to 0, which means this whole thing is just going to be 0 except for our constant term at the end, 10. So that's our y-intercept. When we plug 0 in for x, we get 10. So our y-intercept is going to be at 0, 10. And if we wanted to write our x-intercepts in terms of points, we would write them like this, where we have our y values in the y spot, and then, our x values in the x spot, and then our y values are 0. Now, this also asks us to describe end behavior. So let's look for a minute at end behavior and what that means, and then we'll come back to this question. So we're going to look at two things to determine end behavior. We're going to look at the degree, which is the highest exponent we have for x, and we're going to look at the leading coefficient. If the degree is even, that means both ends of our function, the left end and the right end, are going to be doing the same thing. If the degree is odd, then that means the left end and the right end are going to be doing different things. So let's see what that would look like. Let's start with our even function and positive. So if it's even, they're both going to be doing both ends, the left end and the right end are going to be headed the same direction. And if it's positive, then that direction is going to be up. Now there might be other things going on here in the middle. There might be a couple of bumps or just one bump, or it might be a quadratic and look like a U. So we don't really care about what's going on in the middle for right now. We just want to know end behavior. Both ends increasing. Negative leading coefficients of even functions will result in both ends decreasing or headed down. Again, in between, it might look something like this, or it might look something like this. We don't know. We don't really care what it looks like in between. We're just focused on what the end behavior is. Okay. So now let's look at odd. For our odd functions, we know that they're doing different things, so it's a matter of how do we know which one is going which way. Well, I want you to think of positive and think of what a positive slope would look like. If I draw a line that has a positive slope, it's a little crooked there. Let's say something like this, right? Positive slope. Then my end behavior is going to kind of mimic that in a sense that on the left end of my graph, it's going to be decreasing. And on the right end of my graph, it's going to be increasing. For a negative leading coefficient, I want you to think of a line with a negative slope. And again, our end behavior is going to sort of mimic that because on the left end, our function is going to be increasing. On the right end, our function is going to be decreasing. Okay, so you can think of the slope of a line and kind of lay it over, and that'll help you figure out which end is going up and which one's going down. Or, you know, it might look something like this. So this is the John Travolta of polynomials. So I'm going to lay a curve over good old John here. And so I could put a cubic function here on top of John. I'll just follow his arms. And you can see that on the left end, it's decreasing. The right end, it's increasing. And if I were to connect these with a line, the slope of that line would be positive, right? Same thing on this side. If I go down through his, just trace his arms, I'm increasing on the left and decreasing on the right. And if I were to connect those arrows with a line, my slope would be negative. Okay, so that's how we know what end behavior we're looking at. So now going to look at some of these examples, I want you to think about, first, is it even or odd? Second, is it positive? Does it have a positive or negative leading coefficient? So we've got this is going down and this is going up, so we know that this is odd, right? They're doing different things. And if I were to connect those arrows with a line, the slope of that line would be positive. All right, let's try the next one. This one's going up, this is going down. They're doing different things, so it's odd. And if I were to connect those arrows with a line segment, the slope would be negative. All right, here they're both going up, so that means that it's even, right, because they're both doing the same thing. And since they're both going up, positive. Here they're both doing the same thing again. They're both going down, so they're doing the same thing, so it's even. And they're both going down, so it's negative. And I know it's very small, but if you look for that degree here, you'll see that it's a 4, which is an even number. And you'll see the negative out in front as well. So that's how you can see both of these things from looking in the equation, when you're given the equation. Here we've got the same situation, both doing the same thing, so it's even. Both down, so it's negative. And here they're doing opposite. This is going down, this one's going up, which means that it's odd. And if I were to connect those arrowheads with a line, the slope would be positive. And if you look at the degree, again, I know it's small, but that highest degree there for x is a 3, which is odd. And there is no negative in front, which means that it's positive. All right, 2 more. Well, not 2 more, but it's actually 4 more. But 2 of these are even and 2 are odd. 2 of them are positive with a positive leading coefficient and 2 have a negative leading coefficient. So let's see if we can figure out which is which. Well, we know that if they're going the same direction, like here and here, then they must be even. So I'm going to put an E for even. This one's even and this one's even. For A and C, they're going opposite directions, which means this is odd and this one's odd. So now let's look at which direction they're going. So for A, if I were to connect those arrowheads with a sloping line, that would be a positive slope. For B, they're both going down, so that would be negative leading coefficient. For C, again, connect those arrowheads with a sloping line. It would be a negative slope, so that would be a negative leading coefficient. And for this one, they're both going up, so that's going to be positive. All right. So when we go back to our original problem, we know now that we're looking to see whether this number is positive or negative and whether this degree is even or odd. Since it's 4x cubed, that's odd, and this is positive. So for our end behavior, we know that they're going to be doing different things, right? It's the John Travolta of polynomials. And if I draw the slope of a positive line, just to give me a visual hint, that shows me that for my odd function, my left end is going to be going down, and my right end is going to be going up. So you would say that the left end of the graph is decreasing, and the right end of the graph is increasing. So we can also, now that we've done it without graphing technology, we can also take this into GeoGebra and graph it. And if you already learned how to use GeoGebra in the last recording, this is going to be the same thing. So you can just stop it here. But if you want to see how to graph this in GeoGebra, it's very quick, very easy. I'm going to go to the GeoGebra website, which is www.geogebra.org. It's geo like in geometry and gebra like from algebra. And I'm going to click on Start GeoGebra. And then I'm going to click on Algebra. When the window comes up, you can see a cursor blinking over here. And this is where I'm going to type in my function. So let me get my function. All right, here it is. So my function is 4x. Hold on. I don't see my, oh, here it is. There we go. My keyboard had shrunk down. Notice when you hit that X, the keyboard's over here. So hit the keyboard and it comes up. So I'm going to type in 4x, and then I'm going to use this key to enter an exponent of 3. Then I'm going to hit the right arrow to move over 1. Minus 13x squared, so minus 13, and I'm just typing it on my computer, x squared, minus 37, x plus 10. So that's what we just looked at. And I'm going to hit enter. And so there it is. It's graphed, but I can close this now. I can't see very much of it. I mean, I can kind of see where it crosses the x-axis, and when I mouse over it, it gets bold. But if I want to see the whole graph or a better picture of the whole graph, I would have to zoom out a little bit, and that's where you find it. And then you just click anywhere in the white space, and it'll zoom out. And then if I want to move it again, that's also where I find it. I'm going to zoom out just a little bit more. There we go. So now I can see that it's decreasing on the left end, increasing on the right end, that it increases to here, then it decreases to here, and then it starts increasing again. And that's my graph.